Right? Can students see the video? All right. Okay. So I think, all right. Yeah. So it's just loaded. So very good evening to all of you. Welcome back to week 2 of Vedic Mathematics Part 2. So once again, I'll just verify whether the audio is coming all right, whether the video is also all right. Anybody who has joined, Sharif, are you able to hear me properly? Kindly wait for another 1 or 2 minutes. All right. So I don't yet see any students. So I'm facing a little bit of lag in the mobile phone. So let me just log in once again and see if it is all right. Yeah. So could you all give a thumbs up if you can hear my voice properly and also hear my or also see my video and the slides. Ishita, Seema, Sharif, could you just confirm? Everybody can hear properly? Still no answers. Let me just wait. Yes. So Advaita says yes. Okay, fine. Yes, I think then we'll start in 1 more minute. Kindly wait. So before we start, as usual, I have this slide in the front page. I'm allowing you to guess what are the planets that are being described in this particular figure. Could you just guess what are the planets in this figure? Just write it in order from the smallest planets to the giant planets. Yeah, I can see students started guessing. Okay. I'll just allow you maybe 1 more minute. It's already 7:05. I'll just allow 1 more minute just to see how many of you remember what are the planets in our solar system. All right. I need more answers. Are they coming? The smallest planet here is in fact Mercury. Then we go to Venus, Earth, Mars, which is the next planet, Jupiter. Yeah, but it's bigger. Saturn, then Uranus and Neptune. So these are the order. All right. So Sridevi gives the correct answer, it seems. All right. So let me just start with this lecture by explaining what is the connection between Vedic maths and the planetary system. So in earlier times, actually the Vedic times, which is around 2000 and more years behind, at those times we had very little access to scientific equipments like telescopes, giant radars. All these were not present during that time. So of planets, because position of planets was very important to calculate what year was it, what is the season, and other things, what will be the weather, etc. So in that struggle for finding what is there in the cosmos, many mathematicians and people generally who lived in during that times found out a variety of techniques that are even prominent today when we have a lot of scientific development. So today I'm just going to give a application towards the end of this class. I'll be talking about an application where you can apply all what we have learned in the previous 2 classes. So let us jump straight into today's lecture. It is titled Coherent Math. Coherent meaning clear, something that is very clear without any confusion. So today we are going to let go of any confusing thing that we had already in mind. So before we begin, I'll show you this particular web link. This web link is to the Google form that has particularly the project 1. So I just had a look into this form, but nobody had responded to this form. So once again, I would request all students to submit the project by Saturday. So I will extend it by 2 more days. Actually, the submission deadline was today, but I'll postpone that to Saturday. So you can submit your project 1 up to Saturday, maybe before class, 7 p.m. So is that fine? If that is fine, just give a thumbs up in the chat box. So in the meantime, as I look into the chat box, let me just show you the problems that were present in the assignment or the project. So the weekly project 1 had 3 questions. 2 of them are compulsory and 1 of them is an optional question. So I'll just give a glimpse of the first question. So you have to draw the pattern of the Navashesh from the multiplication table of 5. So all information is given here. You just have to draw what is the pattern formed by the Navashesh. That is question number 1. Question number 2 is specifically an application question. So you have to find what degree the moon makes on the 11th day while it goes around the earth. So I have given a small hint or a small fact that the angle that the moon covers in each day is 13 degrees. So it's just draw any particular art form from this particular Vedic square. So given the Vedic square, you have to connect few numbers. For example, in the class we had connected all the 3 and managed to draw a butterfly approximately. So you can try to draw some figures like that. Need not be very perfect. So this is a creative exercise which is optional. So once you solve for all these 3, you can upload that in the Google form itself. There is an option there. All right. Okay, so Seema gives a thumbs up. So I think I'll return back to the slides today. So as usual, we have a story to begin with. So this time the story is that of a cat and a mouse. So who escapes from the cat? Yes, it's a mouse. Tell me so that he is able to solve the problem of the mouse. Now the mouse explains, I am trying to run away from the cat, but the cat always tries to be behind me, and I'm not having enough speed because I'm a very small creature. It's a tiny little mouse. Now, this is Dr. Elephant. He is a very brilliant person. Now, he is going to suggest a solution. So he told he'll teach a formula. So this mouse knows some mathematics. You should assume that. Now the formula that he gave was drawn in a sheet of paper and it was passed on to the mouse. And after it was passed on, the elephant disappeared. And when the mouse saw that particular diagram, it was written the 9-point circle. Now, we should help the mouse to find a way to escape because 9-point circle is the solution given by Dr. Elephant. So you might have seen when the mouse actually runs, it is not in straight lines, right? It doesn't always run in straight lines. Now, the 9-point circle gives a very good way for the mouse to escape from the cat. Suppose the cat finds the mouse at this point. The cat and mouse are at this point, and the mouse starts running. So the mouse has some speed, and by the time the cat approaches, the mouse is at this point. Now at this point, if he changes the direction, the cat will find it a little bit more difficult to change the direction and chase the mouse. Why? Because cat is a larger animal, it has a larger weight, so it cannot move very fast from one direction to other. So we'll see one of the applications on why Dr. Elephant said so. So let me just conclude with this tiny moral of the story. So learn Vedic mathematics to escape from the fear of math itself. All right. So after this, we'll be learning about how you can escape from the fear of problems, especially word problems, as we progress. And in this session 3, we are going to recap what methods we did and going to practice some applications, especially that of 9-point circle. All right. So let me just see the chat once again. Oh, okay. So some students are saying the video is stuck in between. All right. So I see that from Advaita and Kashif, Muhammad Kashif. So is it fine now? Is the video coming fine? At least in the mobile, I can see it properly. What about others? Is it coming fine right now? All right. I hope it is fine right now. So let us go to the first thing that we learned in the previous class. We were learning about magic numbers, and especially we dealt with two magic numbers. Anybody recalls? Yes, one magic number that we learned was about 9, and we saw how to multiply by 9. So for example, those who didn't recall, I'll just give an example of maybe 13 multiplied by 9. We said that in the Vedic method, you just need to add a 0 in front and 0 behind, and you just have to do 1 minus 0, 3 minus 1, and 0 minus 3. So what is 1 minus 0? It is 1. 3 minus 1 is 2. 0 minus 3 is what we call as vinculum or 3 bar. So this is minus 3. So you can write it as 100 plus 20 minus 3, which is 117. All right. Okay. So Advaita says it's all right for him. I think many of you will recall this method now. Now we are going to learn something that is related to the second magic number, which is 11. So let me just give you a sample, an example here. So I want to check whether a given number is divisible by 11. What do we mean by divisible by 11? So that means 341 divided by 11 will give a remainder of 0. Now remainder is what you get after dividing. So there are two parts to the answer, quotient and remainder. So quotient is the answer to the division. Remainder is what remains after dividing. So in this case, we already know that 341, if you just check, the middle number is the sum of the first and the last digits. So in the previous class, we had already discussed that this is in fact divisible, because if I multiply 31 with 11, the method that we saw was you write 3 and 1 separate by a space in the middle, and in the middle you will just put the sum of the two digits, which is 1 plus 3, which is 4. So the answer is 341. So it means that 341 is divisible by 11. Now I'm going to tell you a method by which you can solve this easily. So I have shown the boxes here, and I have colored the number 341. So every alternate number or alternate digit, I will color it by red, and the ones that I have not colored, I will color by green. So 341, the units place and the hundreds place are red, and the tens place is green. Now what you have to do is add all the reds. What is the sum of the reds? 1 plus 3, which is 4. So I'll write the answer 4 in the red box, and there is only one green, so I'll just write 4 in the green box. Now what you have to do is subtract the two. 4 minus 4. So what is 4 minus 4? Everybody knows by now. It is 0, right? So if you get 0 or 11 or any other multiple of 11, then the remainder of this number 341 on division by 11 is going to be 0. So remember the rule. You have to add all the red, you have to add all the green, and write them down on these boxes. Subtract the numbers in the two boxes, and if you get that subtraction to be 0, 11, or any other multiple of 11, it could be 22, it could be 23, it could be some multiple of 11. If you're getting so, then that particular number that you have checked is going to be divisible by 11. I don't see anybody has written that. So let's go to some more examples. So I have put the second number. Now you have to write in the chat box what is the number that is going to come here in the red box. What is the number that I should write in the green box? I'll just give you 5 seconds. Yes, I'm seeing the chat box. So Advaita, Seema, Sridevi, Kalki, Sharif. Put down your answers quickly in the chat box. 5 seconds are already over. Is anybody with me? So you have to write what number should I put in the red box, what should I put in the green box. I think most of you don't care. So I'll just give you another 5-10 seconds more. Students, are you able to hear me? Any feedback? Okay, Sridevi gives the first answer. In red, I should write 13, which is correct. It's 5 plus 8, which is 13. What about the green? So I think there is some delay in which I am getting this. Is it so? Or students are slow in typing. So what should come in green? Green is direct, right? There is only one number, which is 2. So is the number 528 divisible by 11 or not? For checking that, I just have to subtract 13 minus 2. The answer is 11. And we had learned the rule that if this subtraction turns out to be a multiple of 11, then I know the number is divisible by 11. So that means this is correct. Divisibility by 11 is satisfied. Here is a second example. Now all of you have to type in very quickly. What is the number that is going to come on the red box, on the green box? Quickly, I'll give you exactly 5 seconds. Yeah. Sharif says 9 in the green box, which is not right. Which is not right. So Advaita says 2. Okay, Adityan gives 17 in the red box, I guess. So when you're writing the answer, either write red or green. For red, you can use R. For green, use G. Otherwise, it's very difficult to understand. Yeah. So Sridevi and Adityan says it is 17. It is in fact correct. 9 plus 8 is 17. What about green? Green is direct, right? It is 6. 3 plus 3 is 6. Now, if you subtract, you get the answer as 17 minus 6 is 11. Again, this number is going to be divisible by 11. Here is a last example. This is a 5-digit number. You have to tell me what comes in the red, what comes in the green. Fast. All right. So I see a few fastest fingers again. Adityan gives the first answer, both red and green. Let's verify. So 17 in the red. 8 plus 8 plus 1 is 17. What about the green? Green is just 4 plus 1, which is 5. So if you subtract it, you will get the answer as 12. So 12 is not a multiple of 11. So this number cannot divide 11. Is that fine? So this number does not divide 11. All right. I'm going to give you more problems on division by 11. Now this time, the question is slightly different. I'm going to ask you what is the remainder after division by 11. So here is the setup. So again, we have this number 7934. I have color coded them, meaning all alternate digits I have marked in red, and the others which are not red are green. Now, first of all, I have to see whether this goes or divides 11. So for that, I'll do 4 plus 9, which is 13. 3 plus 7, that is in the green, which is 10. So I subtract these two, I get the answer as 3. 3 is not a multiple of 11. So what I understand is 7934 does not divide 11, but this number that I have written here is what is the remainder. This is the remainder on this division. So I'll give you two simple rules. So earlier, when we were learning the 9-point circle, we learned a concept called as the digit sum. So let me just take a new color. So we called this as the Navashesh, or the digit sum. And we said that the meaning of the word Navashesh is what remains after dividing by 9, or what it says is that if you find the digit sum, you are getting the remainder on dividing by 9. So this is already what we have seen in the first class. Now, what I'm saying is, if you are going to consider what is called as the digit sum of 11, which is exactly what we found here, you are going to get the remainder on division by 11. So what is the digit sum to the base 11? That is what I am explaining. You have to start from the units place and mark all digits alternatively with the same color. So I give you another example here. I'll take the number 1, 2, 3, 4. In this 1, 2, 3, 4, I'll use a highlighter. Let me use red. Not sure if it is going to see. Okay. So 4 Sorry, so this highlighter is bad. Okay, so let me go back to the pen itself, and I'll just put squares and circles. So 4 is the first digit, 2 is the second alternate digit. So I should mark this in square and the other two in circle. Now you add the numbers in the square, you will get it as 6. The sum is 6, and in the circle it is 3 plus 1, which is 4. Now you do the subtraction between the two, you get the answer 2. So this number 1, 2, 3, 4 is not going to divide by 11, but one extra information that you get is that the remainder on dividing by 11 is going to be 2. All right. So have you understood? If you have understood this, kindly give a thumbs up. Okay, I can see some more students saying that the video is breaking. So there is some network issue, I think, coming in between. So please bear with me for that. Yeah. Thank you for the feedback, Seema and Adityan. All right. So we are going to go for the second problem here. This is a question for you. I'll give you exactly 15 seconds. You have to tell me what is going to be the remainder when I divide the 5-digit number 2, 3, 4, 5, 6 by 11. Your time starts now. All right. Your time is going to end. Still no answers. At least tell me what are the numbers going to come in the red and the green. Anybody with the answers? Yeah, Sridevi says it is 18 in red. Anybody saying so? Okay, Adityan says 4. No. So I don't see any correct answer still on the chat box. Yes, Sridevi says it is 12, which is in fact for the red, it is correct. 6 plus 4 is 10. 10 plus 2 is 12. Exactly. What is the number that is going to come in green? Green is going to be 8. Very nice. So if I subtract these two, 12 minus 8 is going to be 4. That is the remainder that I'm going to get while I divide by 11. All right. So I think most of the students have understood. Now just to check your knowledge once again, I'm going to give you one more last example. This is a 4-digit number. This time I'll give you exactly 15 more seconds. So start answering by giving what is the number on the red and the green boxes, and then we'll check what is the remainder. All right, so Sridevi says 4. So that's the first answer that I see. I think somebody has already started. No? Okay. Green is 8. I think that for the previous question. Okay, so I think Sridevi's first answer, I see it as 4. What about green? Who gives the first answer for green? Okay, Advita. Sorry, I pronounced your name wrongly, I think, earlier. So Advita says and 6. And 6. Answer is 6. Okay, so I don't know. We have not yet reached the answer. And green, okay, so green, I think Advita meant to write green. So we have to do a small number, which is 4 minus 6. Now if you are comfortable with negative numbers, this is negative 2. Negative 2 is the answer. So if you are not aware of negative numbers, then what you can do is you can do 6 minus 4. 6 minus 4 is what? 6 minus 4 is 2. You just put a minus sign in front. Now look at this answer, minus 2. Is it a remainder? Can the remainder be negative number? No. So a remainder should always be a number. So if I call the number r to be the remainder, this r should be always less than 11. This is the symbol less than, and the number that we are going to divide by is 11. So the remainder should always be less than 11. You can see the previous examples. The remainder was 3 and 4, which is definitely less than 11. And also there is another rule that the remainder should be either 0 or it should be greater than 0. So here you have a greater than or equal to sign. So what it means is that remainder can be the number 0, 1, 2, 3, etc. up to 10. The maximum remainder on dividing by 11 is going to be 10. Now in this case we are having the remainder as minus 2. Now how do I make minus 2 positive? Yes. So whenever you want to make the remainder positive, what you have to do is you just add by 11. So 11 plus minus 2, which is equal to 9. So 9 is the remainder that you get after dividing the number 4321 by 11. Is it understood? So I think Advita says the remainder cannot be negative. I think that is what is written in the chat box. Many of you have reached the answer till minus 2. But one extra fact that you have to use is that whenever you get the remainder as a negative number, you have to add 11 to it and make it positive. All right, so I can continue from here because I can see students have almost answered correctly. Now I'm going to give you this one problem for you to solve. This was actually posted in the previous class. So anybody who has solved for this, you have to tell me what is the digit that comes in place of t. So I have given a summation. The number is 1t plus t6. The sum is going to be 71. You have to find what is this number or digit. It's a digit. It's a single digit. You have to say what digit comes here. Yes, I can see few different answers coming in the chat box. So Adityan has given the first answer. Yes, it is in fact 5. How do we understand it should be 5? Let us see. Some number plus 6 should be 1. So you know 6 plus 1 is 7, 6 plus 2 is 8, 6 plus 3 is 9, 6 plus 4 is 10, and 6 plus 5 is 11. So only 5 can fit here to get this units place as 1. So if I put t equal to 5, I get 11. So I'll write that extra carry here. And if I have 5 here, you have 5 plus 1. 5 plus 1 is 6. So 6 plus this extra carry will give you this number 7. So the answer is in fact equal to 5. Now let us find what is the digit sum with respect to 11 of this number. So what I am saying is, suppose your friend told that 5 is the answer. You want to check whether it is correct. 1 5 plus 5 6 equal to 7 1. This is what you get. Now what I have to do is, I have to find what is the digit sum when I divide the number 15 by 11. Any guesses? So what I am asking is, what is the remainder on dividing 15 by 11? The answer is quite easy here. The answer is 4. Why? because 11 times 1 is 11. Remaining you have 4 to go. So that is the remainder. 56. What is the remainder? It is 6 minus 5. Recall the red and the green boxes that we had earlier. Here there are only 2 digits. So the one in the red box is 6. The one in the green box is 5. So 6 minus 5 is 1. This is the remainder on dividing 56 by 11. So I'll just write R equal to 4 here, R equal to 1. Right? Now add this up. If you add it up, you will get 5. Now let us check what is the remainder on dividing 71 by 11. So by the red and the green box, you get the answer is 1 minus 7. The number in the red box is 1. Number in the green is 7. So you have to do red minus green, which is 1 minus 7. What is 1 minus 7? It's minus 6. Now you have to recall what we said. Minus 6 is a negative number, so you add 11 to it. If I add 11 to minus 6, you get the answer as 5. And now you have verified that this sum is correct. So the digit sum allows you to check whether the sum that you have done is correct or not. This is true for any digit sum. It's also true for Navashesh or the 9-point circle. All right. So I'll just talk more about this verification rule by digit sum in a later session. So today let me just go to the next topics, because we have our application on astronomy waiting for us. So I'm going to take a quick quiz. You will be given exactly 10 seconds. I'll flash 2 problems in the screen, and you have to give the answer within that 10 seconds. It's quite easy. It is something that we have done in the previous class. So everybody should be able to solve it. So let me flash the question now. You have to find what is the multiplication of 76 with 11 and 22 with 11, and your time starts now. Yeah, hello, good evening, Pradiksha. So you can start by solving the problem. Only 1 second. Okay. Anybody who has come up with answers, at least for one problem, please put that in the chat box. So I can see some students are joining in between. Okay, so Pradiksha gives the answer for the first one, it seems. Okay, what about others? I thought second one was much easier than the first. If I were you, I would have solved for the second one first and then go on to the first. Yeah, hi. So Pradiksha has given the first answer. Let me just write that down for everyone so others can check it. So the first answer, I think, is written as 836. Second answer, yeah, who has given the first? Okay, I think Sri Devi has given the first answer, 242. 242 is absolutely right. This is the same method that we were talking about. Separate the 2 digits and put the sum of the 2 digits in the middle, which is 4. Now here what you have done is separate the 2 digits 7 and 6. When you add it, you will get 13. So 1 is a carry, so this will become 836. That is why it is correct. So hope everyone has understood. Now I'm going to go one step ahead, and I'm going to ask you whether you can do the multiplication of 11 with 3 or 4 digits. For example, the number 305, can you multiply by 11? what is the multiplication of 11 with 305? The answer is yes, you can find what is the multiplication. So what I'll do is, I'll write 305 like this, and let me just use the other color, 11. So 11 is here. 11 I'll write in a slightly different manner. Okay. So I will start from left to right. In Vedic mathematics, it is always from left to right. In schools, you might have learned methods from right to left, but in Vedic mathematics, it's always easier to start with left. So I'll start writing 11 from the left, and you can see I have written 11 in a very different manner. The tens place of 11 is outside the number 305, and the units place is inside. So this is a window. Okay. Now you can see whenever the digits are in the same window, you have to multiply, and when the digits are in different windows, you have to add. So in this case, you have the same window, 3 multiplied by 1, the answer is 3. So the first digit in this multiplication from the left is going to be 3. What is the second digit going to be? So second digit you can easily find. I'll just remove all this stuff. Let me get back to the second digit. So when you find the second digit, you will have to push 11 towards the right by 1 digit. So you will write 11 like this. So remember, in the first place you had written the tens place of 11 outside. Here you will have 2 windows in the second place. These are the 2 windows. Within the same window you will multiply. So 3 multiplied by 1 is 3. 0 multiplied by 1 is 0. So these are 2 numbers. 3 multiplied by 1 is 3. 0 multiplied by 1 is 0. Now you have to add the 2. So here the answer is 3. Here the answer is 0. What is 3 plus 0? It is 3. So you will write here. Now the next step, let me just use the eraser. Next step is also very direct. So one of the 1 is placed here, and the last one is placed here. So 0 multiplied by 1 is 0. 5 multiplied by 1 is going to be 5. Now this time only add 0 and 5. What is 0 and 5? It is 5. So the first 3 digits is going to be 3, 3. Now I am just left with one last digit. What is it? 1 should come outside through the right. So here I have 1, and I have only one box or one window. So 5 multiplied by 1 is 5. So the last digit on the right is going to be 5. The answer is 3355. Now if you imagine this, what you are just doing is you place a 0 in front of 305 and you place a 0 after 305. Like we did multiplication with 9, in this case what you have to do is you just add the 2 digits. 2 adjacent digits, just keep on adding, you will get the answer. So 3 plus 0 is 3. Again 3 plus 0 is 3. 0 plus 5 is 5. 5 plus 0 is 5. So the answer to this is going to be 3355. Now I am going to give you second problem to solve. This is a 4-digit number. You have to tell me what is the answer for this. I'll just give you exactly 15 seconds. Yeah. So the earlier questions, Sridevi, Advita, Pratiksha have all got it right. So try the next problem. Now I have told you the Vedic method of solving it, which is to add adjacent digits. So Adityan gives the first answer. Let's verify whether Adityan is right or not. So the rule starts by putting a 0 in front, 0 behind. Add like this. Adjacent numbers, neighboring numbers you can add. And then write the answer on top. 3, 6, 7, 9, and 5. So I can see what Adityan has written is correct. 3, 6, 7, 9, 5 is the answer. So you can see like 9 multiplication by 11 is going to be super easy from now on. All right. So just to check your whether all of you have got what the method is, I'm going to give you yet another problem. This is going to be a 5-digit number. 56984 multiplied by 11 you have to do, and tell me what is the answer. And this time I'll give you 15 seconds. What is the answer to this? So kindly be fast on your keyboard. Who has the fastest fingers? All right, I think Adityan has the fastest fingers. Let me just wait for one more answer to come in. After that, I'll discuss the answer. This time, most probably, yeah, it will require some more tweak. Okay. So I don't see some other answer coming in. So what I'll do is, let me start solving it. So I'll put a 0 in front and back. You have to do 5 plus 0, 5 plus 6, 6 plus 9, 9 plus 8, 8 plus 4, 4 plus 0. So what is 0 plus 5? It's 5. 5 plus 6 is 11. 11 I'll write like this because 1 has to go as carry to the next place. 6 plus 9 is 15. 5 I'll write. 1 should go as carry to the next place. 9 plus 8 is 17. 1 should go as carry to the next place. 8 plus 4 is 12. Carry. The last digit is 4. 4 plus 0 is 4. Now start using carry from right to left. So if I start writing, this should be 4, 2. This one will add with 7 to give 8. This one will add with 5 to give 6. This will add here to give 2. This will add here to give 6. So the answer is going to be 626824. All right, this was a slightly difficult problem because I had not told you how to deal with carries. Now you can do this problem once again at home and verify whether it's correct or not. All right. Okay. So let us go to the most exciting part of this lecture. We have just 8 minutes. So I'll try to complete the application within 8 minutes. I'll skip some of the slides here and I'm going to directly go to the study of astronomy with Vedic mathematics. So how many of you are interested in astronomy, like looking at the sky, finding patterns in the night sky on the stars, or tracking planets, or seeing the position of moon? Is anybody interested in doing that? So that subject is called as either astronomy or cosmology, depending on where you are. So some people in the West say it is astronomy. Mostly I think the Russians and people in Asia generally call it cosmology. So today we have 2 planets that we'll study. One is Jupiter and the other is Saturn. So all of you are able to guess planets. So one on the left side of the screen, it is Jupiter. The right side, it is Saturn. So Saturn has rings. Jupiter also has actually rings, but it is less visible. All right. So if I had a spacecraft and I could go to Jupiter, then I will observe that it takes 12 years on Earth for Jupiter to complete one revolution around the Sun. So for example, in Earth, we have 365 days, isn't it? So if you go to Jupiter, it is going to be 365 multiplied by 12, so many days. That is 1 year in Jupiter. While in Saturn, the number is still higher, it's 30 years. So suppose in the class, if there is a student of 12 years and he went to Jupiter, then he will only have 1 year in Jupiter. Similarly, if a 30-year-old man had gone to Saturn, his age in Saturn is going to be just 1 year. So just look, as you move from one planet to another, your years are growing very slowly. Okay. Now we are going to see a pattern between Jupiter and Saturn, which is called as a conjunction. So if you look into the sky, someday you can spot Jupiter. It is very easy to spot Jupiter. If you have an application called as Google Night Sky or something, you can show your phone to the sky and it will give you the precise location of planets and stars. So there you can see that Jupiter and Saturn are very close to each other, and on certain specific days these two planets come in a straight line. You can see that there is the Sun, which I'll write by SUN, and the planets are going around the Sun like this. They are going exactly in the anti-clockwise direction. So on some day Jupiter is going to be here, Saturn is going to be here, but on some other day the two planets, they come on a straight line with the Sun. So here I have slightly drawn it differently, so let me just use an eraser. Okay, so let me just redraw that. So they will come in one straight line like this with the Sun. So this is what is called as a conjunction. It's a kind of a rare event, and I'll show you why it is rare. Because of these numbers, these are very rare. Now I'm going to use the 9-point circle that we learned in the last class to learn about this, and I will just use a slightly different 9-point circle. In this 9-point circle, the numbers are going in the clockwise direction. So what I will do is I will redraw this 9-point circle so that the numbers go in the anti-clockwise direction. So hope you have understood what is the meaning of conjunction. Now if you look on to Wikipedia or something, you will see that the conjunction of Jupiter and Saturn happened last year, and the exact date is December 22nd. That means on December 22nd, 2020, Jupiter and Saturn were on the same straight line. So if you were looking at the sky, you can only see Jupiter. Saturn is behind Jupiter. All right. Now I want to predict when is the next time you can see Jupiter and Saturn like this in the same straight line. Is it 5 years? Is it 10 years? Is it 20 years or more than that? So for that, I'm going to use this. So this is a circle. So I can draw what are called as segments of the circle. If you have learned a little bit of geometry. So like this I can draw. So sorry for the poor drawing. Now, if you apply some geometry here, you will get that each of these are 40 degrees. These are just 40 degrees. So I want to see when is the next time like Jupiter and Saturn comes together? So if you see in Jupiter, it is 12 years per revolution, whereas in Saturn it is 30 years per revolution. So there are totally a revolution is 360 degrees. So if you divide 360 by 12, it's very easy to divide. 360 divided by 12 is nothing but 30 degrees. So that means every year Jupiter goes 30 degrees to the anti-clockwise direction, and Saturn is going to go 360 divided by 30. What is this number? This number is going to be 12. You can calculate these numbers at home. So that means when Jupiter goes 30 degrees in 1 year, Saturn falls behind Jupiter and it has gone only 12 degrees. Now, to see when the two planets are going to come in a straight line, you have to find the difference between these two. So do 30 degrees minus 12 degrees. This is what is called as delta, or the difference. This is 18 degree. So in other words, what 18 degree is saying is that Jupiter is going 18 degree faster than Saturn. Since it is going 18 degree faster, and you have to find out when they are going to be aligning each other, look at a running race between Jupiter and Saturn. Jupiter is faster 18 degree than Saturn, which means Jupiter will complete one circle and then catch up with Saturn at some place. Now you have to find what is that position where it catches up. And you will see that it catches up exactly at 360 degrees divided by 18. This is a little bit of more technical mathematics. So which means, oh, I think I made a mistake. So exactly at I think I made a mistake here somewhere. Okay, so 18 degree till this is correct. Now you will see that the catching up is going to happen only after 20 years. Why? Because 360 degree divided by 18. So this is 18 is the degree in 1 year. So this is going to be 20 years. Now that means the next time when you watch the sky, if you see Jupiter and Saturn in the straight line, that is going to be 2040, and that position is shown here. So on December 22nd, 2040, you can see Jupiter and Saturn again aligned together. The third time you can see Jupiter and Saturn together is at 2060, which is after 40 years. And then after one more 20 years, it returns to the same position. Okay, so this was a little bit of complex math that I did not teach you before. But let me just erase everything in the slide once so that you can see this picture, which you can take away. So what you see is a triangle that is formed. So if you attended session 1 of Vedic mathematics, you might remember that this triangle corresponds to the multiplication table of 3. So 3 multiplied by 1 is 3, 3 multiplied by 2 is 6, 3 multiplied by 3 is 9, 3 multiplied by 4 is 12. So if you take digit sum of the right hand part of the answer, what you are getting exactly is this triangle. So 3, 6, 9. Here the digit sum is going to be 1 plus 2, which is 3. Digit sum is going to be 6. So always Jupiter and Saturn conjunctions are going to be on this triangle. So which means you can exactly figure out what date and what position of the planet is in between 2020 and 2040. So this is how you can make a universe map or some map of heavenly bodies and locate in time what is the position of each planet. So hope you enjoyed this discussion. We'll do a little bit more on this discussion maybe in the next class, because I did not explain all the math behind it. I was quite fast there. Sorry for that. So at least many of you have understood that Jupiter and Saturn have got large life, because 12 years to go around the sun in Jupiter and 30 years for Saturn to go around the sun. So hope you enjoyed it. So let's meet up next on Saturday. Just before I leave, I will show you once again that you have a project. So you can submit the project up to Saturday evening. There are 3 questions. You can see the description of the video that you are watching right now after the lecture, and you will see that there is a submission link to a Google form. You can submit all your projects there, and we will discuss the project on Saturday. So once again, thank you all and namaste.